was your little break again?
It was good. You know. So I think 18 was the one we were getting ready to look at. So it tells us a baseball diamond is a square with sides 90 feet long. Okay, so we have this, so we know if it's a square, what are all the angles? Yeah, that is horrible, but you guys get the idea. So these are all right angles. We know all these sides are 90. Okay. Then a batter hits the ball and runs toward first base with a speed of 24 feet per second. So your batter starts here, they're running to first. So here's my batter at this point. Now, if I'm going to give his speed, that means the distance he's traveled has to be a variable. Okay, so we could call that x. So his speed would be the x dt is 24. All right, then it says part A. At what rate is his distance from second base? So he's running to first, but we're talking about his distance to second base. So that would be this side. So let's call that y. Okay, would you guys agree that as he runs, that distance would be getting smaller? So we're trying to find out what rate is his distance from second base decreasing. So we're looking at the rate, so we're trying to find dy dt. When he is halfway to first base. So at the moment, if he's halfway to first base, how far has he traveled? 45. So we're looking at the moment when x is 45. All right. It would be useful probably to find y at that particular instant. How could I find the y when his x is 45? If this is 45, then that means this distance would be 45. Yeah, it's a right triangle, so you could do Pythagorean theorem to find y at that particular instant. Okay. And we know y isn't always going to be equal to that, but at this time, so we could say 45 squared plus 90 squared equals y squared. Let's see. That is not a perfect square, but we would like to break it down. So you could break it into 2025 times 5. So the square root of 2025 is 45. So at that moment, the y is 45 radical 5. Again, x and y are not always those, but at that particular point in time, those are the values. Are we okay with that? So then what formula would I use overall? We need something to take the derivative of. The Pythagorean theorem. Okay, our triangle is right here. So you know that side's y, this is 90. Now, x is the distance outside my triangle. But I know this entire distance is 90. So if from here to here is x, what would we call from here to here? So we could say 90 minus x squared plus 90 squared equals y squared. So if we do our derivative, you could FOIL that out first if you wanted, or we could just do chain rule. The 2 would come down. 90 minus x stays the same. Subtract 1 from the power. times, what's the derivative of the inside? Okay, 90 is a constant, so it goes away. What else do I need beside this? Dx dt. Okay, and derivative of y squared would be 2y dy dt. And then, what would we do at this point? We can, or we can also start plugging in our numbers, can't we? So our x was 45, dx dt was 24, y 45 radical 5, and define dy dt. We get -24 radical 5 over 5. If you wanted to kind of have an approximation of what that was, you could always put it in your decimal. That's about -10.73, negative because our distance is decreasing. Our units, y was feet, and time was seconds. Is that all right? Part B, I think, should be even a little bit easier. Because on part B, you want to know at what rate his distance from third base is increasing. So if he's here, distance to third base is here. And so don't you just have another triangle? We know this is 90. X is inside the triangle. We just need a different variable to call this. So what do you want to call it? A. So on part B, we were trying to find dA dt. You still know your x, your dx dt, so you're going to do it very similar. So I'll leave you guys to finish that one.